All right, so you just looked at a slide that had several differentiation rules for this. And on that slide, you should have noticed there were 3 product type rules. I want to remind you that there are 3 kinds of products that we've studied. We've studied the product between a scalar and a vector. So we can then look at scalar valued functions times a vector valued function. We've looked at the dot product between 2 vectors, so we can take the dot product of 2 vector-valued functions. And we've looked at the cross product for 2 3-dimensional vectors, so we can take a cross product of 2 3-dimensional vector-valued functions. The nice thing about that last slide is we have a product rule for each of those 3 types of products. And to give you an idea as to how this actually works, let's look at the one that I've written up here. We're going to verify the product rule for a scalar valued function times a vector valued function. So the way that we're going to do this is we're going to write out that expression that we're trying to differentiate on the left-hand side. So that's not particularly difficult to do. If we take a scalar times a vector, the way that we did that before, and the way that we'll always do it now, is that all we have to do is distribute that scalar to each of the components of this vector. And so now what that looks like is just the first component will be f of t times u1 of t. The second component will be f of t u2 of t. And that final component will be f of t u3 of t. And so now we have just a usual vector-valued function, and we know how to take the derivative of that. If we want to take the derivative, all we have to do is differentiate each component separately. And now look at each component. We just have a product of 2 functions. This first one, we have a product of the scalar valued function f of t and the scalar valued function u1 of t. So when we take a derivative of that, we can get away with using the usual product rule from Calc 1. So we take the derivative of the first times the second plus the first times the derivative of the second. We're going to do the same thing in that second component. Derivative of the first times the second plus the first times the derivative of the second. And then we'll do the same thing with that last component as well. So this will give me an f prime of t u3 plus f of t u3 prime of t. OK, so that looks sort of symbolically messy, but we actually can separate this long vector into 2 other ones. Notice that in each component, part of each component has an f prime in it, and part of it has a derivative of one of the u1, u2s, or u3s. So what I'm going to do is I'm going to separate this into 2 vectors. In this first vector, I'm only going to keep terms with an f prime. And in the second vector, I'm only going to keep terms with a u prime. So this first one, I'll keep my f prime of t in it. And I'm going to draw a second vector up here, and I'll do it underneath because I won't have enough space. And I'm going to put that second component there. So I'm going to keep that, that second part, the f of t u1 prime of t, down there. All right, so now I'm going to move to the second component and do the same thing. I'm going to keep that f prime of t u2 of t there. And in the second vector, I'm going to keep the f of t u2 prime of t. And now, for the last one, we're going to do the exact same thing. So now that I've separated this, I can actually look at that first vector, and I can see that every component has an f1 or has an f prime of t. So I can factor that f prime of t outside to write this. And if I look at the second vector that I've written, what do each of those components have in common? Well, hopefully you can see it's just an f of t, which I can take outside. So I get a u1 prime of t, u2 prime of t, u3 prime of t there. So now it should be pretty clear that this rule does indeed work. I can just rewrite this first guy as u of t. The second one, notice that we just have the derivatives of u1, u2, and u3. So this is just u prime of t. And that looks exactly like that product rule that we hoped we had. So really, when we're doing this, we have this product rule here because we have the product rule for each component of the product, f of t, vector u of t. The dot product rule works very similarly. The cross product rule works very similarly too, but that one's really a notational pain to write out. But the point is, we have these product rules, and it's good to know how to use them.